Yeah, so hello everyone. My name is Webster and I work in defence, so I'm an applied scientist working in defence at the UK Met Office. And today I'm going to be giving a brief overview of what I've been working on over the past few months, which is to carry out a review of current UK Met Office Arctic forecast capability with a focus on developments required for end-user application. So at the moment, this is in its very early stages of work. We're calling it a piece of discovery work, with the initial requirement coming from our defence customers. However, we are aware that this is a much broader challenge and will likely impact on many different industry services, particularly for the marine sector, for things like commercial shipping, etc. So really, this piece of work is to identify the areas that we need to invest as the Met Office to produce an Arctic forecast capability that meets the needs of our user community going forwards. So these are the initial requirements coming from our customer, and I've separated them out into three different categories, although they are sort of all cross-cutting. We have ice, so navigability, things like ice pack thickness and variability, and I guess how this will change with climate change as well. Open sea routes, so at the moment we have our two key sea routes, the Northwest Passage and Northern Sea Route, open seasonally at the moment, but I guess looking to the future, these open windows will likely be open for much longer with the kind of melting of sea ice. This will likely lead to, I guess, an increase in commercial shipping, that sort of thing. We also have atmosphere, so one of the key areas for this that's been highlighted is to develop our mesoscale modelling, particularly to target things like polar lows, which are rapidly emerging storms in the Arctic, very small in scale, requiring that kind of higher resolution than our global model configuration at the moment. We also have icing and ice accretion forecasting, so this is particularly hazardous for shipping. Any sort of build-up of frozen sea spray on the boats can lead it to kind of be cause instability in the water, causing it to kind of roll, sometimes even capsize. This is an atmospheric and boundary layer issue, but we'll have to take into consideration, I guess, things like the ship's construction if we're to develop any sort of hazard warning index to support our users. And lastly, in that section, we have improving our observation data collection as well, which has been mentioned a few times as being kind of a key issue within the Arctic region. And the final category is ocean. So again, a key area for this that's been highlighted is our mesoscale modelling. And this is particularly for things like fronts and eddies. So I guess sonar communication, that sort of thing. We also have sea level change, so access to ports and how this will change in the future with climate change, which ports will we have more access to, that sort of thing. And lastly, observations again, so our oceanographic data collection as well, which is a key area. So my approach to this so far has been to review UK Met Office Arctic forecasting with an initial focus on our current capability. So what do we have available right now? This is initially focusing on the kind of short range to seasonal. It's been highlighted as a priority area by our customers. And then what can we look to do to enhance that in the future? What can we do with what we have currently available, but also what do we need to develop later on as well to enhance that? And lastly, looking to kind of establish international partnerships and identifying those collaborative opportunities to really help us with this piece of work and to learn from what other people have done as well in this sort of space. So our current capability, these are the sort of three relevant operational models that we have available for the Arctic at the moment. So we have our global coupled NWP forecasting out to about 8 days. We have our global coupled seasonal ensemble model, otherwise known as GLOSSy 6. So we do 2 forecasts daily out to about 7 months. And this configuration is also used for our decadal. And lastly, we have our climate models. So had GEM3 family, but we predict out to hundreds of years, and our climate models have been used for the latest IPCC reporting, that sort of thing, so considered to be highly sophisticated. So looking to the future, for, I guess, office-wide developments that are already in the pipeline that will be of benefit to this piece of work. We have a next-generation modelling system scheduled to be implemented in 2026 when we have our new supercomputer installed. And for this next-generation modelling system, we'll be looking to use a new grid. I think it's called Around Square, which will help with some of those kind of convergence issues in the poles, helping us to kind of resolve some of those features that we're struggling to at the moment. Also, with the next-generation modelling system, we should be able to select much higher resolutions across the world as well, so that should really help with this. In addition to this, the future at the Met Office will be ensemble, so all of our so we will be looking to just focus on, I guess, ensemble-based products, that sort of thing, which is very useful in the Arctic. So in addition to this, we do run several high-resolution regional coupled model configurations across the world. However, we do not have any running operationally at the moment for the Arctic specific. However, in the past, we have contributed and developed high-resolution land-atmosphere model configurations in support of research campaigns. And we have received sort of promising feedback and promising skill from those, and I've included some examples of that, and I think some of these are linked to YOP campaigns as well. So we have the Iceland-Greenland project, Acacia, and also Maximize. And if you want more information on those, I can give you that. But one of the kind of areas that actually is highly relevant that we've contributed to is the sea ice drift forecast experiment. So SIDFEX, which is a community effort to collect and analyze sea ice drift forecasts from lead times from days out to a year. So in the past, we've supported the campaigns such as Mosaic. So this has been mentioned a few times, but I've just included a picture of Polar Stern there, the vessel that was frozen into the sea ice for a year. And I've included an example forecast as well, the consensus forecast there. So the black line is the forecast with the kind of uncertainty ellipses around it. You can't really see it, I'm sorry, but there's a dotted line as well on there, which shows the actual ship's trajectory. So you can see that kind of they were in agreement there, which is very promising. But we have been contributing to the SIDFEX since about 2017 with kind of consistent, skillful, high-res coupled NWP model performance. And I've included a plot there as well of the forecast error of a IABP buoy that we produced a forecast for the 5th of June 2019, and that's a plot of other additional forecasts that were contributed to the SIDFEX as well there, and in the orange line is the coupled NWP model, so showing kind of consistently lower skill there for that. We are also involved in experiments that are looking to improve our forecast accuracy. So one area of this is the sea ice thickness assimilation experiment that Ed Blockley and Andrew Peterson sort of led. So this was where a proto-glossy 6 model configuration was used, and it was found that by assimilating, there we go, that it was found to show a large impact of winter sea ice thickness initialization for the summer forecasts. And this plot, I think, was shown in the introductory sessions yesterday. So I've just included it here, but on, I guess, your left is the summer forecast without that winter sea ice thickness assimilation. So the orange line is the forecast, and then the black line is what was observed. And then on the right, you can see the improvement that it's made by incorporating that sea ice thickness data. So we know sort of what we need to do to improve our forecast capability, and I guess what I've been trying to do is gather various pieces of research together to inform what we need to do within the office, where areas that we should look to invest, I guess. So I pulled it all together here, and I guess 2 minutes left. I'll try and unpack. There's quite a lot of information on there. But I guess I've sort of split it up into three key categories. Observation data coverage has been highlighted as, throughout, that this is an area particularly for kind of the ground basin in situ OBS, very sparse network in the Arctic. So we'd be looking to, I guess, see what we can do in that area, see if there's any opportunities to work in partnership for this. It's been highlighted to me as kind of the key area is actually the information underneath the sea ice, so perhaps kind of gliders, that sort of thing, increasing the number of OBS sensors that we have available there. Next, we have sort of the data assimilation of unused satellite OBS. So I guess it's also been mentioned that, we have really decent satellite observation coverage, which should, I guess, sort of counteract the fact that we have a sparse network of the ground basin in situ OBS. However, we are throwing quite a lot of that observation data away because, so for example, the sea ice thickness data shown to be hugely beneficial, but at the moment we don't have the correctly derived data set to be able to assimilate it. There's also the microwave and infrared radiances, also shown to be hugely beneficial for kind of near surface and atmospheric forecasting. But at the moment we need to develop the complexity of our data assimilation schemes for this, so the snowpack model, I believe. So for the model development side of things, this will be looking to increasing resolution. It's been shown in research that increasing the resolution is beneficial for kind of improving skill across most parameters. It will be beneficial for the mesoscale events required, and evolution of ice edge and transportation of free ice. Also use of ensembles. This is what our future, I guess, will be. But this is particularly true in the polar regions where the natural internal variability of the climate is high. And it's useful for forecasting rare events and extreme values. Another area there is developing our underpinning science. So this is quite a big area, but I guess one of the key things that have stood out so far from the people that I've spoken to is there's lots of low-lying cloud in the Arctic, so we'd be looking to develop our kind of clouds and boundary layer processes as well. And lastly, new capability development. So this is really exploiting our underpinning capabilities, looking to develop new decision support tools. So if we're going to be using ensemble data, a lot of our customers at the moment are used to deterministic based forecasting. So with ensemble data, we'd have to kind of figure out the best way to develop a decision support tools that they will benefit them so that they can make decisions to keep them safe, really, make those useful decisions. Keeping our customers engaged, so through workshops, helping to kind of target priorities for research and development. And lastly, operational support, so where we need to train kind of specialist forecasters, that sort of thing. So next steps, and I'll just do this very quickly, but further research priorities include kind of, the first step would be a gap analysis, so we need to get a little bit more information from our customer first. And then we need to look at more of our in-depth science and modeling configurations to see how well we're performing against those customer, I guess, requirements, and then how far we need to go and what we need to do to the actual models to develop to meet that customer requirement. Model into comparison study would be a great exercise that we could do for verification purposes, but also to highlight, the key areas that need development in our models. Climate capability to be reviewed. It's not an area I've looked at just yet. And then lastly, international collaboration. So I've mentioned this before, but we're really keen to engage on this and to learn what other nations are doing in this space. So yeah, please do speak to me at the end or in the break. But yeah, thank you. Sorry if I ran over.
Thanks a lot, Rose. It's a break, but it's a 1 hour break, right? So I'm sure we can find 1 or 2 minutes for a question. Yeah.
Hi, thanks. Do you make seasonal ensemble forecasts using a GLOW C6? And if you do you make them publicly available?
Freely available, I believe so. Yeah, I'm not entirely sure on that one, sorry. Yeah.
Thanks.